Hi, this is the video lesson on section 2.4, dividing polynomials and the remainder and factor theorems. Enjoy! To begin this lesson, we're going to do a quick review of long division. Take a look at this long division problem. 520 divided by 7. Well, we all know how to set this up. 520 is called the dividend, and it goes inside. The 7 is called the divisor, and it goes on the outside. And so we ask, how many times does 7 go into 5? It doesn't. And so how many times does 7 go into 52? And the answer is 7 times. With 3 left over. Then you drop the 0, and now you ask, 7 goes into 30 how many times? And you know that the answer is 4 times. 28 now with a remainder of 2. So here's the answer. 520 divided by 7 is 74, meaning that 7 can go into 520 74 times. However, there's 2 left over. 2 out of 7. You need another group of 7 to boost this to a 75, but we only have 2 remaining. So we are 2/7 of the way of making another group of 7. So we say 74 plus 2/7. And so this is what we call the quotient. The 2 is the remainder, and the 7 was the divisor. Another way to think about this is that 520 is equal to 74 groups of 7 with 2 left over, plus 2. 520 equals 74 times 7 plus 2. So we are now going to learn how to divide polynomials, and it's going to follow a very similar structure. First, we have x squared plus 12x plus 6 all over x plus 8. So we write the dividend, or the numerator, inside and the divisor outside. So then we ask, x times what will be x squared? Well, x times x will be x squared. So you write the x over there, and then you distribute. So x squared plus 8x. Then you're going to subtract, but I'm going to put parentheses around that to make sure that we are subtracting the quantity x squared plus 8x. Well, 12x minus 8, or x squared minus x squared is 0. 12x minus 8x is 4x. And just like before, we bring the plus 6 down here. Then we ask, x times what will be 4x? And the answer is 4. So you put plus 4 there, and maybe I'll change colors. And now I'm going to distribute that there, and you get 4x plus 32. Because 4 times x is 4x, 4 times 8 is 32. Put this in parentheses, and now I'm going to subtract going down, and now I have negative 26, which is the remainder. And so just like before, we are going to say that this right here equals to the quotient, which is x plus 4, plus the remainder, which is negative 26, over the divisor, which was x plus 8. And so this right here is our answer. Okay? This right here was the quotient. This up here was the remainder. And this down here was the divisor. And if I were to scroll up, you will see that, hey, that was kind of the same thing that we had up there. Okay? All right, I'm going to walk you through another example before you try some on your own. Over here, we put the numerator inside. We put the divisor outside. And now we go x times what is x cubed, and it's x squared. So I'm going to put x squared over here, and then I'm going to distribute like that. So then we have x cubed minus 5x squared. Put this in parentheses so that we can subtract the whole quantity. Negative 4x squared minus negative 5x squared is positive x squared. Then you drop down the minus 11x. And now we go x times what is x squared? And the answer is x. So now let me change colors. So I have plus x. And so now I'm going to distribute this in. So x squared minus 5x. Put this in parentheses and subtract the quantity. Negative 11x minus negative 5x will be negative 11x plus 5x, which is negative 6x. Now you bring in this plus 30. Then you go x times what is negative 6x? And the answer is negative 6. So then I'm going to do minus 6 over here. And now I'm going to distribute this to that. And I get negative 6x plus 30. Put this in parentheses, minus, and you get 0. Which means that this x minus 5 went into this perfectly. Which makes x minus 5 a factor of this polynomial. When you have a remainder of 0, for example, if I do 48 divided by 4, which is 12, and the remainder is 0, that means that 4 is a factor of 48. 4 goes into 48 perfectly. All right, so the answer here is x squared plus x minus 6 with no remainder. So if there's no remainder, you don't need to add the part where it says remainder divided by divisor. All right. Now we are going to have you try some examples on your own. It's 1x squared. Oh, hold on. Actually, you're going to try example 3, only this one example on your own for now. But before that, let me set this up for you first. So you have 6x cubed, but notice here that there is no x squared term. In order to divide nicely, to keep things organized, I suggest that you put a plus 0x squared there. It will be a lot nicer and cleaner to do it that way, okay? And then you have 2x minus 4. All right, so I want you to now pause the video and try this problem on your own. And then when you unpause it, you'll see the answers. So go ahead and pause the video now. All right, here it is. The answer is 3x squared plus 6x plus 10 plus 32 over 2x minus 4. Next, we're going to learn a shortcut in doing polynomial division. And this shortcut is called synthetic division. Now, before I show you how to do it, keep this in mind. When dividing a polynomial by x minus c, place c in the box and the coefficients of the terms of the polynomial to the right of the box. What am I talking about? Well, to set up polynomial division using synthetic division, we draw kind of a box right there, and we write c in there. So we're dividing here by x plus 8, and so here it says when it's x minus c, place c in the box. So in this case, c is negative 8, because you can think of this as x minus negative 8. So c is negative 8. So negative 8 is what you write in the box. Then it says write the coefficients of the terms of the polynomial to the right of the box. So here, the coefficient here is 1, the coefficient here is 12, and the coefficient here is 6. And so we write 1, 12, and 6 across. Now, we leave kind of a line that's blank right here, and we draw a line right there. All right, first step, you drop the 1 to over here. Then you do 1 times the 8, which is negative 8, and you write the negative 8 right over here. Then you add going down. make sure you remember to add going down. So 12 plus negative 8 is 4. So you write 4 right there. Then you do 4 times negative 8, which is negative 32. And then you write it right there. And then you add going down. 6 plus negative 32 is negative 26. I draw a box right there because this right here is the remainder. And 1 and 4 are the coefficients of the quotient. Now, if I'm doing x squared divided by x, then the quotient should be degree 1. So then this 1 and 4 is 1x plus 4. And then you have your remainder over your divisor. Okay? Let's do another one so that you get the hang of it. So here I have x minus 5. So 5 goes in the box. Then you put the coefficients next to it. 1, negative 4, negative 11, and 30. So you have 1, negative 4, negative 11, and 30. Draw a line like this. All right, the first thing you do is take this 1 and drop it right down and write it there. So 1. Then you have 1 times 5, and you write the product right there. And then you'd add. Negative 4 plus 5 is positive 1, and you write 1 right there. Then you multiply it by 5 again. And that gives you 5, and you write it under the negative 11. Negative 11 plus 5 is negative 6. Then you multiply again. Now you don't have to draw these arcs right here. I'm just demonstrating or visually showing that you're multiplying it, but you don't have to write these arcs, okay? All right, negative 6 times 5 is negative 30. So you write the negative 30 in this next spot here, and then you add going down. 30 plus negative 30 is 0. Separate it because this right here will be the remainder. All right, notice that in this problem, we're taking an x cubed polynomial, degree 3, dividing it by degree 1. X cubed over x is x squared. So your quotient is going to be a quadratic. And it's going to take on the coefficients 1, 1, and negative 6. So it's 1x squared plus 1x minus 6. And there's no remainder, which means that this right here is the answer. All right, now you're going to practice this process with a whole bunch of practice problems. All right, I would like you to pause this video and try these 4 problems. Pause the video now. All right, here are the answers. Go ahead and take a moment to check them. You might need to pause the video so you can check each one. The one thing I want to point out is that in number 4, we are missing a linear term. We're missing a term that has x in it. And so you need to put a 0 here as a placeholder so that you have the coefficient of x cubed, the coefficient of x squared, the coefficient of x, which is 0, and then the constant term minus 10 over here. All right, take a moment to look at this, and then we'll move on to the next slide. Next, we're going to talk about the factor theorem. The factor theorem says this: if f of c equals 0, then x minus c is a factor of f of x. And it works, the converse works as well. If x minus c is a factor of f of x, then f of c equals 0. Plugging in a value into a function and getting 0 means that x minus that value is a factor. So let's look at this example. Solve this really ugly cubic polynomial, degree 3, equals 0 if 1/2 is a root. Now 1/2 is a root means that f of 1/2 is going to give you 0. And so that's what I have over here actually. Note 1. Since 1/2 is a root, f of 1/2 is a 0. Now immediately look up at the factor theorem. That means that x minus 1/2 is a factor. X minus 1/2 is a factor. Now if x minus 1/2 is a factor, that means that dividing the polynomial by x minus 1/2 will yield a remainder of 0. So let's verify that. We're going to put 1/2 in the box, and then we're going to do some synthetic division. 12, 16, -5, -3. And now we're going to do some synthetic division, okay? All right, so drop the 12. 12 times 1/2 is 6. 16 plus 6 is 22. 22 times 1/2 is 11. -5 plus 11 is 6. 6 times 1/2 is 3. -3 plus 3 is 0. Ah, indeed, the remainder is 0. Which means, yeah, x minus 1/2 is a factor. Well, the other factor is going to be 12x squared, 22x, and 6. So I'm going to have 12x squared. Oh, so we're going to have 12x squared plus 22x plus 6 equals 0. Now, why is it 12x squared? Why is it x squared? Because when you divide an x cubed by an x, you get an x squared. So that's 1 degree down. All right, so now this problem says to solve. So we're not done yet. We have to finish solving. So let's factor out a 2, and then we get 6x squared plus 11x plus 3. And then our hope is that this will factor. So let's see if it factors. I split it to 3x and 2x and 3 and 1, and indeed it factors. Okay, now we're going to use what we call the zero product property, which means that this gives us x equals 1/2. This gives us x equals -1/3. And this here gives us x equals -3/2. And so we were able to solve this by first factoring that polynomial using the factor theorem and also using synthetic division. So we factor this over here to be this right here. And by doing that, I can further factor this quadratic into this, and now I can easily identify my 3 solutions. Lastly, we are going to explore the remainder theorem. Here's what the remainder theorem says. If the polynomial f of x is divided by x minus c, then the remainder is f of c, which means that f of c is the remainder and the remainder is f of c. So what does that mean? It means that if I want to find the remainder of a polynomial divided by x minus c, I can do the division and get the remainder, or I can simply just evaluate f of c. This will become clearer when we do these examples. Example 1. Use the remainder to find the remainder when this polynomial is divided by this x minus 1. Now, one way to get the remainder is to actually do the division. So then I pull 2, but look, there is no x to the 22nd term. So then I have to put a 0 there. There is no x to the 21st term. There's no x to the 20th term. And then you have this, and then it's just going to take a long time, and it's going to be really, really long, yeah? And so we want to find the remainder some other way and not have to do this polynomial division. So how are we going to do that? We are going to use the remainder theorem, which says that the remainder is simply f of c. So all we have to do is look at this and go, oh, c is 1. So all I have to do is evaluate f of 1. 2 times 1 to the 23rd minus 1 to the 19th plus 5 times 1 to the 14th minus 3. And so I have 2 minus 1 plus 5 minus 3, and I have 3. So that's the remainder. the remainder is 3 because f of 1 equals 3. The remainder theorem tells us that if you want to get the remainder, just evaluate f of c. Now we're going to use this theorem in reverse now, in example 2. Use the remainder theorem to find f of -4 for this. And so we're going to use the remainder theorem in reverse. And what I mean by that is that I am going to divide. So if this value is c is -4, then the factor that we're dealing with, or not factor, but the divisor that we're working with, so I'm going to call it divisor, is c plus 4. Oh, sorry, not c plus 4, x plus 4, okay? All right, so -4 goes in the box, and I have 2, -5, 2, -1, and I'm going to perform the polynomial division. Now, when I do that, I am going to get -217, which is the remainder. Well, the remainder theorem says that f of -4 is the remainder. So this is a way to find f of -4. Now, this is a tricky concept, and it's going to take you some time to really let it sink in. So just look at this kind of as a whole, and just kind of let it sink in. Reread the theorem, maybe rewind and rewatch this portion of the video. Lastly, we're going to look at example 3. Example 3 here says, is x minus 1 a factor of the polynomial, of this polynomial? Well, if x minus 1 is a factor, then when you do this long polynomial divided by x minus 1, the remainder should be 0. And so one way to verify this is to actually do the division. So you have 1, 3, 2, -5, -20, and 19. So this would be actually doing the division, and we would want this to be a 0, or the remainder to be a 0, if x minus 1 were to be a factor. So let's go ahead and do this polynomial division using synthetic division. 1, 1, 4, 4, 6, 6, 1, 1, -19, -19, 0. Hey, the remainder is 0, which means that x minus 1 is a factor. There was nothing left over. So the answer is yes. Okay? Now, another way to get this remainder is to use the remainder theorem, which says that f of c is the remainder, and the remainder is f of c. So another way to get the remainder here is to evaluate f of 1, because you have x minus 1, so c equals 1. All right, so let's try it. 1 to the 5th plus 3 times 1 to the 4th plus 2 times 1 cubed minus 5 times 1 squared minus 20 times 1 plus 19. If we simplify this, we would get 0. So f of 1 is 0, and so 0 is also the remainder. And so that is the conclusion. Yes, x minus 1 is a factor of this polynomial because f of 1 is 0 and f of 1 is the remainder. Here is also evidence that the remainder is indeed 0. Okay? All right, so we went over both ways of verifying that x minus 1 is a factor. All right, that's the lesson. Sorry it went on a little bit too long. See you in class.